In the nervous system video, I drew a picture of a neuron, and I kind of labeled it, but I didn't talk about how neurons talk to one another, because it's not always it goes straight from your foot to your brain. So I'm going to draw another neuron for you, hopefully a little bit better than the last one. So there's the soma. I'm drawing the axon right now. It's skinny. Okay, so the nucleus is right here. These are dendrites. Dendrites. All of these little branchy off things. Okay, and then at the other end is another soma looking thing. This is actually the soma, but it's sort of thick in the same way, and this has little fingery button things at the end, and these are called terminal buttons. That's good enough. Terminal buttons. And terminal is sort of from the same root as the terminal of an airplane, like you terminate your trip here, or maybe you begin your trip there also. And how this works is, this is one neuron cell, one neural cell, and then the next neuron just connects right here. Okay, there's the next dendrite of the next neuron. And I'm not doing the best job drawing this next one, but you get the idea. There's the soma of the next one, and its axon goes on to maybe your brain, maybe yet another neuron, whatever. And so then you can have a whole string of these, and I want to zoom in on this little area, because some interesting things happen in this area when you have a signal here from maybe your finger or maybe from your eye, and then the signal comes down here, goes through the myelin sheath and everything, and ends up here. And then before it switches to the next neuron, it goes from an electrical signal to a chemical signal really quickly, just for a second. So I want to zoom up this box just on that little area. I guess I have to keep that in the picture. So there we go, there's our zoom box. And the end of this terminal, or the terminal button of the first neuron, I'm going to draw like this. I have no idea if they actually look like this, but this is the way that I see it drawn. And then the dendrite of the next neuron is sort of drawn like an innie to the other's outie. Okay? And so what happens here is that the terminal button of this neuron has little chemicals stored inside of it, ready to go. So I'll just draw them as circles because it takes too long to draw an actual molecule. But there's some little molecules in here, and they're just stored, not doing anything, and then when the signal comes, when it gets excited, then they are released. They come out into this little, they're not actually connected, it's just this little space in between. And the reason that is useful is because this other one has little receptors on it. Okay? And they're ready to receive these molecules. So they get sent out, and this all happens really fast. The electricity happens very quickly, and then this little chemical process happens very quickly also. So let's say this one, it gets all the way over here and excites this receptor. So now this receptor is excited, and the signal can pass on down this neuron, to wherever it's going. And in this little synaptic cleft, I should label that, that's what it's called. I have to spell. Synaptic cleft. Hopefully that's somewhere close. It might be a different letter here instead of an I. But in the synaptic cleft, we have the neurotransmitters, yet another label that I should put. neuro, like neuron, neurotransmitters. Okay? And I don't think these have a very special name. They're just receptors for the neurotransmitters. And so they come across when the first neuron gets excited. These come across and pass. They're not passing a lot of information. They're just passing, yes, you should activate. It doesn't say, oh, this is a hot or whatever. So the thing that we need to talk about these neurotransmitters, the thing that's useful for psychology, since I'm not doing just a general bio course, is let's say we have another scenario that I will draw separately. Okay? And in this scenario, we have pretty much the same setup. We have this one with some green particles ready to go, and then we have our other neuron ready to receive the circle type chemical, and something interesting happens. Something that looks like the circle molecule. Maybe it's circle with something else on the end. It's not exactly the same. Or maybe it is exactly the same, but it just came from somewhere else. Maybe it came in from this direction. And then these things end up activating the receptors on the next neuron. Will the next neuron fire? Yes. If they fit, then it will go. It doesn't actually, this brownish red neuron does not know that it came from, it doesn't know whether it came from this yellow neuron or not. It just knows that something fits in its receptor, and therefore it will send its signal. That's the only thing it cares about. And so the interesting question, of course, is where do these bright orange molecules come from that look just like the neurotransmitters? And those could come from medicine. This is what quite a few types of medicine actually are. The types of medicine that work on your brain. And this is the part where I should list a few, I guess. Serotonin and dopamine. And these all have different effects, complex effects. They affect different people differently, and it's just, I don't want to get into what each neuron or what each neurotransmitter does in this video, but maybe I'll make more videos on that. What I want to get across right here is, well, I should label these. This is the normal frame. This is just normal functioning of the body, okay? And then in this one, this is an agonist. Agonist. That's what these orange ones are. And the word agonist just means that they look like the other one. They do the same job as the green ones over here. And the other special case that I will draw over here is an antagonist. Antagonist. And what this is it does sort of the opposite of this, and I'll show you. We have that neuron, we have the other neuron again. I'm getting sloppier every time. So here are these, ready to be sent out and activate the other one. But something else comes along. Let's see, I have to draw the little receptor parts, and then something else comes along, this time bright green. Oh, I can't use green, I just used that. Red for antagonist. It comes along and sort of covers over this hole. Maybe they're shaped like that. Okay? And so they don't really fit. They don't go into the hole and cause it to fire. It doesn't do that. But it also, let's say the yellow one gets activated right now. The yellow one gets a signal in and releases these little guys. Maybe one of them will make it in, but the rest of them will be blocked and they will just deflect away or be reabsorbed. But this brown neuron, the second one, won't have enough stimulation to actually fire, because there's this all or none principle, all or none principle, that if one of these things make it in, it's not going to fire. It takes a majority, and every neuron's a little different, but there's a certain threshold. Threshold is a good key word. Threshold that you have to have, maybe 50% or more of the little receptor things filled up. And so the antagonist will come in and block the effect of whatever natural neurotransmitter is in there. They can shut down the signals, basically, at the neuron to neuron level. And then an agonist would have the same effect as the neurotransmitter. I have to rephrase this. The red particles coming in, if you take a pill that's an agonist for serotonin, it will have the same effect as if your body just made more serotonin, or more of these neurons were firing. And if you took a pill that was an antagonist for, say, dopamine or for serotonin, then it would have, I don't want to say the opposite effect, because that's not entirely true, but it would lessen the effect of whatever molecule you are antagonizing. So these words are pretty similar, antagonist and agonist. I think my way to remember this is the antagonist of a story is like the bad guy. If the green guy is your hero, the green guy is trying to accomplish some goal, the protagonist, okay, he's Luke Skywalker or whoever your hero is, and the antagonist is getting in the way, and he says, no, you can't accomplish your goals. He's the antagonist. And then this other word just kind of, it's antagonist without the ant, I guess. And I don't really see why this means what it means. But that's enough for me to remember it, and I think you have a good understanding of, or a good at least premise of how these pills would work. So I'll leave you with that.